So thank you very much for being here and attending our tutorial on SpeechBrain. We work really hard on this project that I had the pleasure to lead. Personally, I never worked that hard in my entire life, and yeah. So today we are really happy and excited to share with you what we have done. So the title of the tutorial is SpeechBrain, a general purpose speech toolkit. And today, I, Mirco Ravanelli, from Milan, Montreal, Titouan Barcollet, Université d'Avignon, Akurawe, Aalto University, are trying to give you a kind of guided tour towards this toolkit. And hopefully, at the end, you should be able to better understand what is SpeechBrain, what you can do with that, how we design, what are our future plans, etc. So let's start. Let me start with the outline of the tutorial. First of all, well, we will follow a kind of top-down approach where we are starting with a gentle introduction, and then we will progressively add more and more technical details. So yeah, I will start with an introduction. Then Titouan will give you a toolkit overview with all the available resources. We will explain how to do training and inference with SpeechBrain. Then Aku will we will do a break here. Then Aku will tell you something more about the architecture of a SpeechBrain, how we manage hyperparameters file, how we manage data.io things, etc. After that, we will show you some real examples of recipes. Particularly, we'll show you one recipe on Speaker ID and one recipe on ASR, and we will guide you through all the steps needed to develop, for instance, a speech recognizer. And finally, we will conclude the tutorial with, Titouan will conclude the tutorial with summary of the roadmap and how to contribute, and also the conclusions. All right. Introduction. So the first question that you might have here is, what is SpeechBrain? SpeechBrain is an open source all-in-one toolkit based on PyTorch. So our goal here is to speed up research and development of speech and audio processing technology. So we wanted to create something hopefully flexible, easy to use, modular, efficient, and with good documentation. And we already have many resources available to the community. You can take a look at the website, our code repository, our tutorials, and our pre-trained models on Hugging Face. And of course, during this tutorial, you can definitely play with these resources. So I will encourage you to take a look at that. Okay, so some history. Actually, we announced this project a couple of years ago at INTERSPEECH in Graz. We were able to start actually developing the project in February 2020, curiously, right before the pandemic. So we had to switch from physical work here in Montreal to remote working. But that turned out to be very good anyway. So we were, after a little bit more than 1 year of heavily development, this March 2021, we were able to release the first public version of the toolkit. The toolkit actually is, we had a very positive reaction of the community, and SpeechBrain is now growing very, very fast. Just a few numbers here. We started development with 18 core developers. Now we have 54 contributors. We have a couple of scientific advisors, Yosha Benjo and Renato De Mori. We got 2.9K stars on GitHub in only 5 months, more than 400 forks. And I'm very proud to say that, we have contributors from all over the world. So just for fun, I say that, the sun never sets on SpeechBrain. And that's true, because when I go to bed, there are people, there are collaborators that are waking up, I don't know, in Taiwan. And then there are people from Europe working on that, and then again North Americans. So that's pretty exciting working these days on these very international projects. All right, the second question you may have is, why another toolkit? So to reply a little bit more to this question, let me give you an overview about the role played by open source toolkits in the development of speech technology. So actually, even before this deep learning revolution, open source toolkits were there for speech, especially for speech recognition, and especially based on C++. Examples were HTK from Cambridge, an amazing toolkit, CMU, Sphinx, Julius, Raz from Aachen, and also Caldi, which is still used a lot today in the community. But then at some point something happened, and there was the so-called deep learning revolution. And what we have seen is that with the deep learning revolution, the technology changed drastically. And we also have seen the development of kind of general purpose libraries. One was Theano, developed here at Milan, then TensorFlow, and more recently, even PyTorch. And thanks to these Python-based libraries, it was possible to develop more flexible speech processing toolkit that quickly appear. Some of them are actually task-specific. I can here mention Asteroid for speech separation, PyNode for diarization, Sidekit for speaker recognition, and the recently released S3PRL for self-supervised learning. But also there are many of such toolkits for speech recognition, like I mentioned here, DeepSpeech, ReturnRNN, PyTorch Caldi, Espresso, and Lingvo. Some of these toolkits instead are designed to support multiple tasks. And I can here mention FAIRSEQ from Facebook, ESPnet, very famous, Nemo from NVIDIA, and the last born of the family, which is SpeechBrain. So there are similarities and differences across all these contributions. They are all valuable contributions. So my suggestion really is to try more than one toolkit and use the one that best fits with your needs. So probably there isn't the absolute best, but depending on what you have to do, you might choose the one that you think is the best. And of course, we are happy if you think that this is a SpeechBrain, but we recognize really high value also in other toolkits, these ones, but also, Caldi too, that we have seen, that you might have seen before, are all valuable contribution for the community. All right. So one peculiarity of SpeechBrain is that we designed it from scratch to support multiple speech processing tasks. So nowadays, technologies like speech recognition, speech enhancement, speech separation, speaker recognition, emotion recognition, language identification, speech synthesis are very close with each other because they share the same underlying technology, which is deep learning. So these tasks these days are connected. In the past, it was different, right? Because when I started working in the field, like speech recognition was based on GMM and HMM. Speech enhancement mainly based on signal processing techniques. So very different things. But today we have the same technology, and we can easily, or at least more easily, create a single toolkit for all these tasks. And the reason why we call this project SpeechBrain is exactly that. So we want a single toolkit that, just like our brain, is able to do many things at the same time, like recognizing speech, understand its content, but also figure out different meta information of the signal, like who is speaking, the emotion, the language, and so on. So we have, since the beginning, this multitask idea in mind. So there are several advantages to have this kind of single, flexible, and multitask toolkit. So first of all, you don't have to jump into many code repository and we can, within a single toolkit, you can preserve the same code styles, standards, and programming languages, and this save a lot of time, right, during the development of speech technologies. Another reason is that, today there is growing interest towards complex speech pipelines. Virtual assistants are examples. Virtual assistants are complex speech pipelines. If you think about that, there are different components that you have to integrate: voice activity detection, keyword spotting, speech recognition, natural language understanding, and so on. It will be really great to have, really easier and great to have a single toolkit that can combine eventually all of these blocks. So the other reason why we think it's very important to have a single toolkit is that, we can explore better transfer learning and joint training techniques across tasks. We can explore better, speech enhancement plus speech separation, speech enhancement plus speech recognition, speech separation plus speech recognition, or even more fancy things like combination of text-to-speech and speech-to-text. So I think we are ready now to explore more this part about cooperation and joint training across technologies. What is challenging actually is, it's true that, as I mentioned before, we have a single toolkit. We have a single technology for different tasks, which is deep learning. But it's also true that, each task has its own specificity, and, creating a single toolkit is still not easy, right? Because of that. So that was the most challenging part of the project, and we hope we have found a good solution to this problem. So other question you guys may have is, what can I do with SpeechBrain? So we currently support many technologies. One is speech recognition. We support, standard things like sequence-to-sequence with RNN, sequence-to-sequence with transformers, RNN transducers, hybrid CTC, and attention, and many other things that are very popular these days. We also support speech enhancement. Here, we have many recipes. The two maybe more interesting one are the metric GAN plus, which pretty powerful system that will be object of another presentation here at INTERSPEECH, and then mimic loss that combines speech enhancement and speech recognition. But also we have other baselines here based on transformers, etc. We also have support speech separation. Here we have some kind of popular models like ConvTASnet, dual path RNN, and setformers. We also support spoken language understanding. Here is instead of mapping from one signal to a text like speech recognition, we map from one signal to kind of output semantics, and we have a different baselines and on different data sets for that as well. We also support speaker recognition, both speaker identification and verification. Here we have X vectors and also a kappa TDNN, which turn out to work pretty well. And also we have speaker diarization. Here we have, for instance, one system based on spectral clustering, which works pretty well on AMI and will be object of another presentation here at INTERSPEECH. But we can actually do already much more because we are growing very fast. With the latest version of SpeechBrain, you can do also other tasks. You can do speech translation, language modeling, language identification, sound classification, graphing to phoneme. You also have support for multi-microphone signal processing like beamforming, localization, etc. And very recently, we are also diving into EEG decoding of brain signals. So we already have one recipe for that, and we plan to extend this a lot in the future. There are already some ongoing work. We are going to merge the first text-to-speech baseline with Tacotron, music generation, voice activity detection, and as mentioned by Dan, we are going to do work on the final state transducer as well with the integration with Caldi. So yeah, there is work in progress with K2 projects. All right, what I can do with SpeechBrain. As I mentioned, we already support many tasks. We have competitive baseline results, and here is what we have. We currently have 46 recipes for 20 data sets, 26 pre-trained models that we share on Hugging Face. So here is the performance that we can have on speech recognition. We have, with transformers. With LibreSpeech, we have CNN plus transformers, which give us 2.3 on test clean. But when we use wave2vec, we have 1.9. We have pretty competitive performance on common voice as well. And also, if you want, on LibreSpeech, we have 13.8 with the CR-DNN model and 8% when we plug the wave2vec model. All right, that's not all. So we also have baselines for other tasks. We have pretty good numbers on VoxelLab, the kappa TDNN. We have equator rate 0.69 here. As mentioned, we're also working on diarization with AMI. We have the state-of-the-art on voice bank with metric gun plus, and also the state-of-the-art in separation with the SEP former on Wall Street Journal 2 mix and Wall Street Journal 3 mix. All right, so we will see that later. But one question here is how can I train the model? So we have many recipes, but in all the recipes, what you have to do is to train a model with this kind of things. So Python, train.py, hparams.yaml. So the first one is a training script. The second one is the hyperparameter file. Our hyperparameter file is actually based on an extended version of YAML that we call hyperpy.yaml. This extended version, I think, is very helpful to make the code a more cleaner, elegant. So as you can see here, we are not using a kind of plain list of hyperparameters, but we declare the hyperparameters along with the objects that are using that. And there are some kind of advantages for that. One advantage is that you can there is always a visible connection between the hyperparameters and the object using it. Like for instance, here we declare these feature objects that is MFCC in this case, and here there are the corresponding hyperparameters. So we know that the NML is used by this MFCC. That's kind of clear, make the debugging easier and more transparent in general, the hyperparameter specification. The other good reason for which you need to, we think this is a good solution is that, when we load the hyperparameter file, we already have this object initialized, and users should don't have to take care about this, boilerplate code for initialization. Train.py instead is the training scripts. We will see that in detail later. What happens here is, is based on, we created a brain class to make the training loop easier. And yes, that's the philosophy that we are following here is to make visible whatever we think users will modify the most. For instance, the forward computations that goes from the input signal to the output predictions are visible. The compute objective computation that goes from the output prediction of the network to the loss function are visible, and also the data IO pipeline. So one nice thing is that you don't have to jump. Nobody knows where in the repository to find these computations. You can find them in the train.py directly. All right, we are not providing a solution for training only, but we are also providing some solution for inference, and in particular we design some kind of interfaces for for easy inference on your model. Tituan will go explain that in detail, but normally with few lines of codes you are able to use your pre-trained model. Most of the pre-trained models are now available on Hugging Face, and specifically we have 26 pre-trained model on Hugging Face now, and more will come. Design principles. So, and we try to did our best at least to create something which is easy to use. We try to develop intuitive modules that are easy to interconnect with each other. We try to make the code very Pythonic and to maximize the use of PyTorch routines as much as possible, because with PyTorch we can decide to do computation on CPU, on GPUs, or we can also have support for automatic differentiation. We try to stay with a lean software stack. So in SpeechBrain you have Python. On top of Python you have PyTorch, and just on top of PyTorch you have SpeechBrain. There isn't any other level of abstractions here, which we think can make life of the users a little bit easier. And another important remark is that you can plug PyTorch compatible code in our toolkit without further modifications. So we design it such that if you have an external model and you would like to plug it it should be easy. We also try to minimize the number of mandatory external dependencies, and this makes the code more stable and also easy to install. Okay, so transparency, replicability. This is also in common with other open source projects. So we are really promote open science. We want to have researchers ideally to publicly release the code, and we structure SpeechBrain to make that easier. So yeah, on our side, what we have done is to create recipes on publicly available data, and hopefully allow the community to easily replicate our numbers. So we share the pre-trained model on Hugging Face, and also we share all the logs, all the things as well, to make sure that people are able to replicate the numbers that we are achieving with our models. So accessibility is another important thing. We are releasing SpeechBrain under a very permissive license, Apache 2, which is just the same as Caldi, ESPnet, and I think Nemo. And in particular, we are putting special care on making the code understandable by a large user base, which includes students and practitioners. So yeah, we want SpeechBrain not just to serve research purposes, but also to serve educational purposes. And yes, for making that true, we need to write a lot of documentation, and I hope we did a good job here. Yeah, I can share with you my experience. I used this SpeechBrain actually last semester in my course at UDM, and yeah, it turned out at the University of Montreal. It turned out that students were able to implement speech pipeline without too many difficulties, and even though the students were not speech experts and with a huge variability in their preparation of machine learning. So I really hope SpeechBrain will be considered for that as well. Other features that we would like to remark: we support multi-GPU training with data parallel and distributed data parallel. We support dynamic batching, which is an important feature for sequence processing toolkit. We will maybe see this later, but we support large-scale experiment with web datasets. Basically, now datasets are so big that it's very hard to even copy the dataset in a local computation node where you run the network. So what we are doing here is to use another solution that is able to efficiently read the files from the shared file system without harming the file system itself. All right. Also, we use a lot, on the fly augmentation, feature computation on both GPU, CPU, and GPU. So you don't have to save a lot of information in your disk. You just give in input the waveform, and SpeechBrain normally do on the fly augmentation and feature computation without needed to store many versions of the dataset on disk. Also, yes, we have this special collaboration with the Again Phase. We are trying to put our models on Again Phase, but at the same time, we are trying to take advantage of their models, like Wave2Vec, etc. So a few words on documentation. So we have documentations at different levels. Level number 1 is tutorials. We have, written a lot of tutorials that are designed to help newcomers not only getting more familiar with SpeechBrain, but more in general, getting more familiar with speech technologies. And yeah, that's pretty good. And we will see a couple of tutorials in this presentation. So we also have templates. Templates are, simple, well-documented recipes that contains all the parts necessary for a working system. So we have templates for different types of problems like sequence regression, sequence to sequence like speech recognition, and sequence classification like speaker ID and many other tasks. And we consider that a good starting point because you can typically, if you would like to, adapt SpeechBrain to your recipes, you can copy and paste a template and modify the things that you need to modify, such as put data or whatever. Also, in terms of docstring, we are pretty consistent. So for every function class, we have kind of standard docstring where we describe the functionality, the arguments, and also quite systematically we provide an example that people can run. So we try to stay aligned as much as possible to the great documentation provided by PyTorch. So in particular, this example is really, really important for users to figure out what is going on. And needless to say, we also have inline comments when needed. All right, quick comparison with other toolkits. Again, there is a lot of value in all the other solutions. So let me just itemize at high level what are some differences. So for what regards FAIRSEQ versus SpeechBrain, I think, one issue here. Well, actually, FAIRSEQ supports sequence-to-sequence processing. SpeechBrain supports speech-to-speech processing, but actually, speech processing is more than a sequence-to-sequence processing because we also have regression tasks like speech enhancement separation, classification tasks like speaker recognition, clustering like diarization, and also signal processing techniques. Another very valuable toolkit, really very Pythonic, is Nemo from NVIDIA. Nemo has kind of industrial orientation where you have kind of efficient, ready-to-use models such as Jasper, QuartzNet, and CitrusNet. SpeechBrain has also many ready-to-use models, but is more focused on research and education aspect. Then there is ESPnet, another very, very valuable contribution, probably the most similar contribution to SpeechBrain. Both ESPnet and SpeechBrain are academically driven. One difference is that ESPnet started years ago as an end-to-end speech recognition library, and then grew up to support different tasks. SpeechBrain is a more recent project, and it is designed from scratch for multiple tasks. So we designed it such that combining the technology and developing new recipes is extremely simple. All right, comparison with other toolkits in terms of performance. Here is a kind of table where we show the tasks that we found in common and the recipes that we found in common. There is some note of caution here. So sometimes the comparison is not as easy as you might think because, in some cases, some toolkits use extra data, like self-supervised learning data with Way2Vec, or some other toolkits use extra data for language model. So the comparison, I mean, it's not always apple to apple, but what is important here is that in SpeechBrain you can have competitive performance if you want. All right. Yeah, I will encourage you to take a look at our paper that we put on arXiv. There are many information there. Take a look at our resources that are here. I don't know if we can copy and paste that, but what you can do is to just Google SpeechBrain and you will easily find them. We also have to thank our sponsor that give us some kind of money to hire students or collaborators working on these exciting projects. And let me quickly announce here that, SpeechBrain is growing very fast. We have big plans for the future, but we need more help from the community. So if you are a contributor and you would like to contribute to the project as a contributor, you have an idea, you have something that you would like to see in SpeechBrain, just contact us. If you are a potential new sponsor, please contact us. We are opening this new call for sponsorship, and we usually need sponsors to hire students and collaborators to grow, maintain the toolkit, which is actually very, very challenging, especially now that we are growing quite fast. So if you are interested to hear more about that, just contact us at this email. What you can do today, if you want, is just to help us gaining visibility, just go to the repository and add a star. That's for free and will help you gaining visibility if you appreciate our efforts for the community. We also have to thank our institutional partners, l'IA, Laboratoire Informatique d'Avignon, University of Cambridge, University of Sherbrooke, and BioIASP in Taiwan. And of course, needless to say, I have to definitely thank all my contributors or the code development team that worked so hard over the last 1 year and a half to release this toolkit. Okay, so that's all. I think I don't know how we can proceed here. We can you guys can ask questions in the chat, and we hopefully are able to provide answer. And if everything is fine, I will say that Titwan can go ahead with an overview of the toolkit.
Right.
So did you guys figure out how to reply questions, etc.?
Yeah, and some questions can be written directly on the chat, and then we can also invite people, I guess, when they raise hands. But I guess we can do so, like for audio intervention, we can do it at the end of my part, right before doing the break. I think it's the best place,
Right.
And then of course at the end of the tutorial.
Sure, let's do that.
And for the question on the chat, I guess you guys can just reply while presenting. We have some, so okay.
All right, so Titwan, feel free to go ahead.